Get it. I first want to make sure that the sound system is working and everyone can hear okay. Back there, good. Well, imagine that one morning you get up and you're in the habit of turning on the television to watch the news about traffic and weather, and you do that. But this morning something's different. Instead of your favorite commentator being on, there's this astronomer guy. He's a tall, geeky sort of a guy, and he's talking about 2 asteroids. And you think, what's going on here? They got rid of my favorite news program and they put on an Astronomy 101 program. So you change the channel, and guess what? You see the same guy. A little different camera angle, and the sound quality is a little different. You change the channel a second time. The same guy again. A little different camera angle and a little different sound quality. And you think, what's going on? Is everyone in America suddenly becoming interested in astronomy? And then you think, wait a minute, maybe there's something important going on here. Maybe this is news. So you turn back to your original channel and you start to listen. And he's talking about 2 asteroids. There's a smaller one. It's codenamed Houston. It is slated to impact the planet October 21st, 2010. It will have an energy impact equivalent to about 12,000 of our largest hydrogen bombs. It will be impacting someplace in the Middle East. The good news, this astronomer tells us, is that we know very accurately when and where it's going to impact, so we'll be able to evacuate people and there should be no loss of human life. There will, however, be significant economic damage. And when he says Middle East, you, of course, associate that immediately with oil. But then he goes on and he says, now I want to talk to you about this second asteroid, and it's codenamed Schmidt. I don't know why he picks that, but that's what he did. And Schmidt is approximately 150 times the mass of Houston. It's going to hit the Earth sometime in 2076. So they're pretty sure it's June 21st, but there's a little uncertainty in the exact hour. So because of that uncertainty, we don't know exactly where on the planet it's going to hit because the Earth is turning. He explains all that stuff very carefully. And he says, now, we're not going to be able to evacuate unless we can leave the planet because this is a planetary event. So that's the bad news. But the good news is we do have a little bit of time. So with some help from NASA and perhaps the Europeans and the Japanese and Chinese and the Russians who all have launch capabilities, we can do something to mediate this, to mitigate this. We can either use a hydrogen bomb to blow off some material, or more likely, we can use a continuous thrust and gradually deflect this large object so that it will not strike the Earth. And you're wondering if this is all real or what. And then come the questions from the press. And before the press starts to ask questions, your immediate question that you had was, well, when did Washington hear about this? And you're guessing Washington heard about it 24 hours earlier, and the CIA just gave this guy permission to talk. And that was the first question, by the way. When did Washington hear about this? And the astronomer, Mark Spalding is his name, he says, well, Washington has known about this for years. And as a matter of fact, they've worked very hard to discredit any of these reports. And it's just now that we've been able to get this out. And you think, my gosh, this is really sad, because if we had known about this earlier with that Houston thing, we could have prevented this. We could have used some of these space techniques to deflect Houston, and now we've run out of time. Well, folks, the story I just told you is completely fictitious, unless 2 words are changed. Change Houston to oil depletion, and change the second asteroid, which was called Schmidt, change that to global warming, and then the story I told you starts to take on a semblance of reality. It's symbolic in a number of ways. And I believe that oil depletion and global warming will be the 2 biggest issues of this century. They will be bigger than the Iraq War. They will be bigger than World War II. They will be bigger than the Cold War. These will be the defining issues of our coming generations. So I'm going to start out by talking just a little bit about those 2 issues, oil depletion and global warming, because what I want to get to is the positive part. You know, I guess it was Sarah Palin recently said she doesn't buy into all this gloom and doom. Well, neither do I, because actually there's some very exciting things that come out of this. I think the end message, when we start to do something about this, is very positive and not negative. So let's look at what the facts are and also some of the non-facts concerning oil. Let's go back in time to 1930, beginning of the Great Depression. But oil had a really good year that year. We discovered in the United States more oil than any year prior or since. 7.9 billion barrels of oil were discovered. The price of oil would have fallen way below $1 a barrel, except that the federal government moved in to do what OPEC has done since, to limit production of oil, so it was stabilized at $1 a barrel. 1930, remember that date. We move ahead to 1952. All during the Great Depression and World War II, the United States was a net exporter of oil. The dollars were coming into us, not going away on average. 1952 was the last year that was the case. After 1952, we were a net importer of oil. In that year, we produced 2.6 billion barrels, which is about 1/3 of what we are now using, just to give a yardstick. 1956, an oil geologist who worked for Shell Oil by the name of M. King Hubert submitted a paper. This was at a petroleum conference in San Antonio, Texas, and it was entitled Nuclear Energy and Fossil Fuels. And using various mathematical methods, he predicted that U.S. oil production would peak in 1970. Now, a lot of people scoffed at this, and perhaps for good reason. Prior to this date, a number of people had been forecasting that oil was running out. The mathematical methods they used generally were bogus, and history proved them to be wrong. In the worst cases, what people were doing was basically they were looking at what the known reserves were and looking at the rate of use and dividing those two numbers and coming out with a time when we'd run out. And it wasn't dealing properly with the fact that each year we were discovering more oil. And the proper mathematical account of that was not given. Dr. Hubert did the math right. Move further ahead to 1965, and this year was the year where discovery for the world peaked. Remember, for the United States, it peaked in 1930, so now 35 years later, and you'd expect there to be a delay because the United States was technologically advanced, so you'd expect us to have found the maximum amount of oil before the rest of the world was doing that. So 1965, the world discovered 57 billion barrels worldwide, and we were only using 12 billion barrels that year. So it's like, you know, picture earning $57,000 and spending $12,000. That sounds pretty good. Your bank account is growing, and indeed it was in 1965. 1968 is an event that will be remembered only by a few people, myself is one of them, the great electric car race between Caltech and MIT. Back in 1965, when world oil production, discoveries peaked, I got interested in electric vehicles as a means of combating smog. In the Los Angeles area, back in the 50s and 60s, smog was a big problem. That was conventional photochemical smog, hydrocarbons, nitrous oxides, those things. And so I felt that electric vehicles would be able to relate to that and could potentially be an answer. I also was aware of the problem with batteries. So I had contacted about a year and a half earlier people at MIT and gotten them interested in the idea of a cross-country electric car race. And they accepted the idea. There was a lot of publicity at the time on this. MIT converted a Corvair to electric drive, and I had already converted a VW bus, a 1959 VW bus, as you heard earlier. There were 55 recharge points set up across the country. US 66 was used for most of the driving. And as was said earlier, Caltech won, but just by a little bit. We won out of 210 hours. We won the race when corrected for penalties. We were very smart at figuring out how to do that. We won by half an hour. So it was a very exciting event for me. Did it meet its mark? I'm not sure that it did. The goal that I had was to focus attention on battery development, and I don't think it really met that mark. In 1970, guess what? Dr. Hubert was right. We didn't know it right away until maybe a couple of years, but United States oil production, in fact, peaked, reached its highest value that year, and since has been going down. So as they said in the oil industry, old Hubert was right. And what's important was not just that he was right. You know, sometimes you get the right mathematical answer because you just happen to be lucky. You know, you didn't know that 2 and 2 was 4, but you guessed luckily and you got it. Well, what was important here was that Dr. Hubert had the mathematical methods as well as the right answer. The methods he used were right. So looking at that, in that year we produced $3.4 billion and we consumed a little bit more. We were obviously at that point already a net importer. Now we look at, I got to mention, I left a couple of things out. We had those oil shocks in the 70s and 73 and 78 where we were not really encountering world oil shortage, but apparently what had happened is the people in OPEC had figured out that United States oil had peaked and that as a result they'd be able to charge more for oil, and so they did. And there was a little hiccup, and that hiccup was the oil shock when, you remember, if you're my age, those long lines to get gasoline at gas stations. And we first ended up, gas went up to something like 55 cents a gallon, which was outrageous. And then when we thought it couldn't go higher than that, it went to $1 a gallon in 1978, and then dropped back a little bit. So we see in 2005, this is now getting to what we're involved with presently, world oil production in that year, and I got all of this data from the government, from Energy Information Administration, which is part of the Department of Energy. The average production for the world for that year was 84.58 million barrels per day. And the average cost was $52.55 per barrel. We go 1 year later, the number is 84.54 million barrels per day, and the cost has gone up. So what you see happening is the volume of oil, the amount of oil is not changing much, but the price is going up. You all knew that. 2007, again, pretty close to the same volume of oil, a little bit higher price. And what's interesting is if you look at the discovery numbers, how much new oil are we finding? Remember back in the early part of the century, the 20th century, we were finding each year far more oil than we were using. In 2007, the total discovery of oil was about a quarter of what we used. So that's kind of like having a job and you earn $20,000 and you spend $80,000 that year. Obviously, you're going into your bank account or something, or borrowing money. I don't know. 2008, this year, production numbers are just a little bit higher. The average cost has gone up quite a bit. Often people talk about this and they say something I think that is very misleading. They say, well, at some point, at some point demand will exceed supply. And of course, that's not possible. You can't use something that you don't have. If we produce X number of barrels of oil, the